Glass is a very rigid, stiff, brittle material. Brittle means that it remains nice and straight and solid and flat until you bend it too far, and then suddenly it breaks all at once. And so the energy of the bending builds up inside the glass and sort of becomes potential energy, you might say, until we reach that rupture point where the glass breaks all at once. When the glass breaks, it's actually relieving that stress through the creation of fractures. So the fractures are relieving the stress. The number of fractures tells you how much stress there was, and also the speed of the crack propagation tells you how much stress is there. So if you have a small amount of stress in the glass, the fracture is going to propagate and kind of meander. It's not going to be a straight line. And if the glass happens to be under a lot of stress, then that fracture is going to go zipping right across the glass, and there may be many of those fractures zipping across the glass all at once. Tempered glass is the most extreme example of that because it already has stress built up inside of the glass on purpose to the tune of at least 10,000 pounds per square inch of internal stress. So when you relieve it, it just blows up all at once because there's that much stress and you need that much fracture surface, meaning cracks, to relieve all of that all at once. In fact, with tempered glass, if you break it and it goes, landing down on the ground, sometimes you can still hear it popping like popcorn because even the smaller parts are releasing more energy and fracturing even after the big sheet fractured.